This same LPDDR4 signal was measured on the same oscilloscope with two different probes, both with sufficient bandwidth. Why did one probe cause loading issues and the other did not? Hi, in this video, we're going to review the basics of probe loading, learn the two common input impedance profiles, RC and RCRC, and see how probe impedance affects the accuracy of your measurements. First, what is probe loading? When you connect a probe to your circuit, it acts as a load, drawing current from the circuit. To get the most accurate measurements, you want a probe that draws the least amount of current, meaning a probe with the least amount of loading. High impedance probes have the least amount of probe loading. You want a probe with low capacitance and high resistance. At high frequencies, equivalent to high-speed digital signals today, the resistance and capacitance varies across the frequencies. This standard way of looking at probe impedance is an input impedance profile plot. The plot relates the probe impedance versus frequency. Let's take a look at two common profiles. The first is RC, shown in red. At low frequencies, the input impedance is high, driven by the input resistance of the probe. At high frequencies, it intersects the capacitance of the probe and decreases. This is what we call an RC input impedance profile, since it's first dominated by the resistance and then the capacitance of the probe. This plot is a common input impedance profile for many oscilloscope probes, including Keysight's Infinimax Gen 1, 2, RC, and Ultra probes. Now let's look at the blue trace. It starts out with high impedance, but then quickly drops as it intersects with the capacitance of the probe, where it hits the mid-band impedance. Then, over 6 decades of frequency, it maintains a similar impedance until it finally decreases at the very high end. This profile is called an RCRC architecture because from low frequencies to high frequencies, it's dominated by the probe's resistance, then capacitance, then resistance again, then capacitance again. This is very typical of other Keysight probes, such as the Keysight Infinimax Gen 3 and 3 Plus probes. An RC probe has the highest impedance across the widest frequency range, but an RCRC probe has higher impedance at very low and very high frequencies. So which probe is more accurate, an RC probe or an RCRC probe? It depends on two factors. Number one, what is the bandwidth of the signal you are trying to measure? And number two, what is the source impedance of the signal? Let's go back to our simple circuit diagram. You should consider the source impedance relative to the probe impedance. If you have a signal with high impedance, then an RC architecture is best so that the probe loading does not affect the circuit under test. If you have a signal with low impedance, then an RCRC architecture would work because the probe impedance would still be high enough. What types of signals have high impedance? There has been a recent trend in memory buses used in the latest DDR and MIPI standards to use an on-die termination or ODT modes to improve signal integrity and save power. The ODT mode switches termination impedance back and forth between low and unterminated high impedance. When the ODT impedance goes high, the probe impedance needs to be high enough to reduce probe loading. These high impedance modes can be found in low power DDR and DDR4 and 5, MIPI D-Phi, C-Phi, and M-Phi. Let's go back to our signal from the beginning. This is an LPDDR4 signal transitioning from low to high impedance modes. The RCRC probe has issues transitioning to a high impedance state and probe loading effects can be seen. The RC probe shows a better representation of what is happening as the signal transitions to a high impedance state. The comparison shows that the RC probe has less probe loading and thus more accuracy. Now that you understand the importance of probe impedance, you can choose a probe with the accuracy and bandwidth you need. Keysight's Infinimax probing system has probes with both RC and RCRC architecture, and they cover 1.5 GHz all the way up to 30 GHz. For more information on Keysight's Infinimax probing system, visit our website.